Hi everyone. Today we're going to take our knowledge of igneous rocks a little further and test your skills a little bit. Now, what I've got on the screen right now is the Earth Science Reference Table's Igneous Rock Identification Scheme from page 6, and I've placed pictures over the names of these key rocks, these key igneous rocks. So let's take a closer look at these and try to notice a couple of patterns. Now first, we take a look over here. And let me reduce this just a little. All right, reduce it a lot then. Okay, so now taking a closer look at this, over here we have our intrusive rocks going all the way across right here. Those are the ones that cooled the most slowly and the deepest underground. And here we have our extrusive rocks, which have the finer texture. They cooled above ground and they cooled more quickly. So now let's take a look on the left side where the felsic rocks are. The felsic rocks are on the left right here with the felsic minerals. Notice these ones are lighter in color than these ones are. These ones also happen to be slightly less dense, and they're higher in aluminum and silicon. These ones over here, the mafic ones, are higher in iron and magnesium. They're darker and they're a little more dense. Now let's take a look at these individuals a little more closely. So first, over here, we have pegmatite. Now, notice pegmatite has enormous crystal grains, larger than 10 centimeters. Larger than 10 millimeters, which is an entire centimeter in diameter. Very, very big crystals, cooled must be very slowly beneath the ground. Here you have your typical granite, crystals between 1 and 10 millimeters in size, coarse texture. Here, now we're into the extrusive ones. We have a fine texture of rhyolite. Crystal grains are smaller than a millimeter. And now, above this, higher up, are the two that cooled extremely quickly above ground, so fast that these two have what's called a glassy texture. And this glassy texture is evident in the obsidian. However, it's not evident in the pumice. And the reason why it's not evident in the pumice is because the pumice is all puffed up with trapped gas. It has a vesicular texture. But if you could grind both of these two rocks into powder, the powder would look identical. The obsidian had no trapped gas in it, but the pumice did. Now let's go all the way to the right and look at our mafic rocks. Our coarse grain mafic rock here is your gabbro. Big crystal grains between 1 and 10 millimeters of olivine, which is the lighter colored green one, and pyroxene, which is the darker colored green one, and a few small specks of maybe some hornblende or amphibole in here, which adds a little bit of blackness as well. Now, the exact same minerals can produce this black rock when the crystal grains are smaller, when they're less than 1 millimeter, faster cooling, fine texture. This is your extrusive basalt. And here you have your very fast cooling vesicular example, which is scoria. So notice we're getting smaller crystals as we go up, and we're getting lighter color as we go to the left. In the middle, we have a really cool rock. You can see that it's coarse grained by the size of these crystals. It's obviously intrusive, but these rocks in the middle only have 2 minerals. Follow it straight down. You'll notice the only 2 minerals that are in this particular rock are going to be plagioclase and, actually 3, plagioclase and maybe some amphibole and maybe some biotite. Nothing but black and white minerals in this particular rock. This rock is known as diorite. Kind of reminds me a little bit of like a Dalmatian dog with those black and white spots. That's what diorite looks like. Okay, now let's go a little further, and we're going to take another look at an ESRT, an interactive ESRT right here. Very similar to the ones that I showed you, except different pictures. Here's the whole chart. Here are the minerals that go into making these rocks. There's your potassium feldspar. Here's your quartz. There's your white plagioclase feldspar, your black biotite, your black amphibole, your green olivine, your darker green pyroxene. Now, here's your pegmatite with the very large crystal grains. Here's your granite with the regular crystal grains between 1 and 10, coarse grain. Here's your fine-grained rhyolite. And here's your pumice, all puffed up with gas because it's vesicular. And here's your obsidian, which is the same mineral size and composition as pumice, but just didn't have the gas. Gabbro, this picture does not look as green as my picture did. It should look greener. Here's your basalt, smooth, fine-grained, fine crystal grain because it's extrusive. And basaltic glass is a very, very fine grain, almost like an obsidian, like a mafic obsidian. Okay, now let's try some problems. First, this should be pretty easy because you'll remember this. The vesicular texture means that the rock has trapped something during solidification. What is trapped in that rock during solidification? The answer is gas pockets. Okay, now, in order for those gas pockets to form in there, what must be true about the way that that rock cooled? It must have cooled very what? Please answer that. And the answer is it must have cooled very, very rapidly or quickly. Very fast cooling. Okay, now let's summarize what we know in this table beneath. I'm going to start at the right. Intrusive rocks form inside the earth. Therefore, the rate of cooling is slow. Because of that, the grain size would be what? What would be the grain size? Please write it down. Use the numbers from the ESRT. And the answer is the grain size would be greater than 1 millimeter. If you said 1 to 10, I would accept that too. Now, what kind of texture does a grain size of greater than 1 millimeter give that rock? You know what word not to use. What sort of texture does it give that rock? Please put your answer right there. And the answer is a coarse texture. Now, please provide 2 examples of coarse textured igneous rocks that are plutonic. Coarse textured, intrusive igneous rocks. Please provide 2 examples. And you could have provided 4, really. Granite, gabbro. You could have also included diorite and pegmatite. Now, let's take a look at rapid cooling or fast cooling beneath the surface. If it cools quickly, what's the grain size going to be? Feel free to peek at the ESRT. And your answer, the grain size is going to be less than 1 millimeter. Again, check in the ESRT. What do you call the texture that results from a grain size that small? Less than 1, what would that texture be? And your answer is, that's a fine texture. Now, please provide 2 examples of a rock that is extrusive and has a fine texture. Okay, your answers should have been basalt, rhyolite, and you also could have put andesite, which would have also been acceptable. Now, let's get extreme. Very fast cooling above the surface, very rapid cooling. That's going to result in a rock that is basically microscopic or non-mineralic. No minerals detectable in there. Can't really see them with the naked eye at all. So, what would be the texture of a rock with crystals so incredibly fine? Again, check the ESRT. And the answer is glassy. And please provide 1 example of a rock with glassy texture. And your answer is obsidian. You could have also given us scoria. You could have also given us even pumice. Okay, let's go down for a couple more problems. Number 1, take a look at the photograph. Here's a black and white photograph, even closer looking. What is it about these pictures that lets you know for sure that this must be an igneous rock? What clue here leads you to believe that this is an igneous rock? Well, the answer is interlocking or intergrown crystals, like pieces of a jigsaw puzzle. Now, how would such a rock have formed? With big crystals like this, how would that rock have formed? Please place your answer right there. And the answer is that the rock would have cooled slowly beneath the Earth's surface. Let's go down a little bit. Now, what observable feature tells you that these rocks are igneous? Well, the answer is these rocks have a glassy texture like this. You're not going to find glassy texture in any other kind of rock but igneous. Now, please describe how a rock with a texture like this would have formed. Pause the video if you must. And the answer is rapid cooling above the Earth's surface. And finally, the next big test right here. Look at these. Look at the texture of these rocks right here. This rock has what kind of texture? Describe the texture. I know it says what feature leads you to believe it's igneous. That's the same question. What is the word? What is that texture? Please place it right there. And the answer is the texture of that rock is vesicular. And now, please, final question. How is this rock different from this? Why did this rock form differently than this rock? Why does it look different? Both of these two rocks have glassy textures, similar mineral compositions. So why in the world does this rock look so different than this rock? What was different about this rock's formation that made it look different from number 2? Please place your answer right there. And the answer is it cooled quickly, but it lacked the trapped gases. That's what gave it the vesicular texture. All right. Good job, everyone. Thanks for paying such close attention. Leave questions at the end. There'll be more in store for you tomorrow. Have a great night.